Hi, today we're going to be talking about DataLabeler, our Nets 213 final project. Now, what exactly is DataLabeler? DataLabeler is basically a service that, given a bunch of images, returns dense image captions for these images. Now, what exactly is a dense image caption? Basically, a dense image caption is given an image, a dense image caption is a very detailed description of that image, including the various objects and things in that image. Now, why exactly would we want to create a dense image caption? Basically, our main motivation is to create more training data for machine learning models, things like multimodal LLMs like Momo. And Momo was our main inspiration to create this project. And they found that to generate these dense image captions, crowdsourcing was a perfect tool, specifically having the workers record audio descriptions of the images. And the reason crowdsourcing is a perfect tool for this task is because humans are really good at image identification and identifying different objects and images, which is something that machine learning models and LLMs are still not very good at. Now, what are some similar technologies that exist to our application currently? Like we mentioned before, Momo, I imagine in the research they use a similar crowdsourcing technology to generate image captions. Now, if someone was trying to generate image captions and they didn't really know anything else, they'd probably just try to stick it into an LLM and have it generate an image caption. But that kind of defeats the purpose. What we're trying to do with our project is we're trying to generate dense image captions as training data for these AIs. We're trying to make these AIs better. Another service that exists similar to our technology is Scale AI. But Scale AI doesn't necessarily generate image captures, they generate other sort of training data, like maybe training data for self-driving cars. All right, here's how you do our task. So first, you have to sign up as an Amazon Mechanical Turk worker ID. From there, you can search my username, AKAUKUNTLA, into the HITs. And then you'll see one of our 5 tasks. You can accept one of these tasks, and then you'll see this survey. And the survey has a link to our app, which you can open in a new tab.
Here's what our application looks like. This is the front page where the user can input their mTurk ID. And for this example, I'll just put in a default. Um, and then they move into an instruction page where they can read the instructions for the task. These should give enough information for the user to complete it, especially if they've come from the mTurk task. Then from our database, we pick a random image that still needs captions, and we display it to the user. And the user now has all the time that they need to record or upload an audio file that describes this
You can
image.
submit the audio. And I completed the task here, and it says congrats on completing the task. But if the audio is too short, or if it's not descriptive enough, then it will reprompt you to re-record the task. Now that I completed the task, I can copy this code, go into Turk, put this code in, and submit my task. And it says HIT submitted, which is good. And then after about 5 or 10 minutes, it should show up as approved for the task in your dashboard.
So quick look at the internals of our database. What we have here are 3 tables, images, captions, and verification. So the images table is the main table that we're going to take a look at right now. This has the image IDs as well as the final captions for any image if they've been completed already, if the aggregation for these images has been completed. And there's also a captions table which stores all the captions that have been accepted for all the images. And finally, there's a verification table, and this is what allows us to go back to mTurk and accept or reject the submissions on the platform for theoretically payment in the future. And quick look at kind of what the admin interface would look like. If we go to DataLabeler, the docs, we can see that in order to get the captions for the images, what we can do is we can just make a request to this endpoint here, get caption images, and this will give us the caption for each of the image IDs. And at the moment, it requires no authentication. So here you can see all of the captions that have been completed so far.
So basic rundown of our method is that the client first logs into our application using his or her mTurk ID, and then they're given an image to describe, in which they can either record live or upload on a previously recorded audio. And then after, we pass this audio through our quality control test. And if it passes, then the worker can get their hit code, which they can go over to Mechanical Turk to redeem. So they're incentivized to create a quality audio by only getting paid if they do. And in terms of our quality control mechanism, we first convert the audio to text and check if the text is at least 80 words. And if the text references at least 2 of the 10 keywords that are associated with the image that we use an LLM to generate, which is essentially gold standard. And then once it passes these, we save the response to our database. And once an image has been captioned by 3 workers, we aggregate these 3 responses into one singular long response that using an LLM like ChatGPT, and then we store the final aggregated response in our database. And yeah.
So how did the results turn out to be? We ended up with this set that has a lot more features than we thought it would. For example, here we can see that the street was identified as Chatham Street, which is highlighted by this small sign shown in dark red. We have also seen some features like a stop sign in the background, garbage cans on the side, and much more. But how does this translate to numbers? Essentially, our aggregated workers turned out to have 3 times more than what an LLM would generate, and the prompt for the LLM is shown below. We tried to be as fair as possible to the LLM to not generate text that would be so much less dense, and we still ended up with this amount, which shows the efficacy of our model. This also showed, like after our analysis, we also saw that the worker quality only increased when we aggregated by the 3 workers that we were aggregating across. And that was a perfect correlation between the number of workers that we would add to the quality. What were the takeaways of this project? We discovered that crowdsourcing is very strong when it's applied right, but only when it's applied right. If we didn't have good quality control metrics, we wouldn't have had this good of aggregation results. So essentially, if you had a worker say that like this image had a blue sky, and the worker had like, oh, there are trees in this image while there were not trees, the aggregated data would contain both, and it would make it even worse. So this is something to think about more. We also discovered that scaling an open source tool is hard. We had to pay for Lemonfox, we had to pay for Mega, we had to pay for other parts in the tech stack that would not be readily like available in an open source tool. So what were the next steps that we need to take? From now on, we'll need to worry about scalability. We'll also need to worry about collecting real data by entdeckers. We will proceed by doing more cost analysis on how efficient this tool is in collecting data for open source models like Momo and more.